In this presentation, we will be talking about offshore wind farms as marine structures, balancing clean energy and ocean ecosystem impacts.
Hello, my name is Elena Jed, and today I'll be starting off this presentation by covering the history of wind farms. Offshore wind energy dates back to the early 1990s, with the first commercial offshore wind farm being built in Denmark in 1991. Early offshore wind projects were small and mainly served as testing grounds for developing and improving the technology. Offshore wind development then expanded throughout Europe, with the UK later building its first offshore wind farm in 2003. In the United States, however, offshore wind developed later, with the first commercial project starting in 2016 at Block Island, Rhode Island. So how do wind turbines work? Wind turbines turn wind energy into electricity by spinning large blades. As wind moves across the blades, it creates a difference in air pressure that causes the blades and rotor to spin. The rotor connects to a generator either directly or through gears that increase the speed of rotation, which produces electricity. So one current wind farm includes the Vineyard Wind 1 project, which was the first large-scale offshore wind farm. It's located about 14 to 15 miles off the coast of Martha's Vineyard, Massachusetts. It includes 62 offshore wind turbines, which can generate enough electricity to power more than 400,000 homes and businesses. So finally, the overview of negative impacts to ocean ecosystems. Historically, some of the main negative impacts associated with offshore wind farms include noise pollution, bird collisions, disruption of seafloor, and water quality. Some studies also suggest turbines may change local wind patterns, ocean currents, and ecosystem structure, though many impacts are often local and may lessen over time. However, negative impacts are reported more frequently, being especially linked to birds, marine mammals, and ecosystem structure.
The immediate impacts of offshore wind are often strongest during construction. Pile driving can produce intense underwater noise that may disturb or displace marine mammals and fish, while seafloor installation can temporarily disturb benetic habitats. At the same time, turbine foundations can create new hard surfaces for mussels, barnacles, and other organisms to colonize. Long-term impacts are more complex and can include both risks and benefits. Some species may avoid turbines because of noise, vessel traffic, or altered habitat, while others may benefit from reef-like structures that increase local shelter or feeding opportunities. Seabirds may face collision or displacement risks, depending on species behavior and wind farm placement. Offshore wind affects people as well as ecosystems. It can reduce greenhouse gas emissions by replacing fossil fuel electricity, which benefits the global climate, but it can also create conflicts with fisheries, shipping, tourism, and coastal viewsheds. This makes offshore wind a classic environmental trade-off: cleaner energy on one side and localized ecological and social impacts on the other.
There are 5 actions that an individual could take to combat our research, the first being acoustic monitoring and temporal construction bans. During migration and spawning, the noise detection systems, this would help to reduce noise pollution and prevent injury to marine life. The second action is balancing climate benefits. That would help optimizing their design and placement to maximize carbon reduction while minimizing environmental impacts. There are 5 actions that an individual could take to combat our research, the first being acoustic monitoring and temporal construction bans during migration and spawning seasons. As the noise detection systems, the reason that would help us would be reducing noise pollution and preventing injury to marine life. And then the second would be balancing climate benefits. This would help in optimizing the design and placement to maximize carbon reductions while minimizing environmental impacts. The summary and overview of our project is that the wind farm industry has gotten so large, especially over the past 20 years, with new inventions coming each year to make them more safe for the environment and marine life. If more safety aspects and monitoring nature-inclusive designs are implemented, then there might be a potential for wind farms to be safer for the environment and marine lives and everybody overall.